Okay, YouTube, in this video we're going to look at graphing a system of nonlinear inequalities, or not just specifically only linear inequalities. And so we're going to graph these the very same way that we've been graphing systems up until now. And so that is to say that we're going to take both of our inequalities and first rewrite them as equations and go graph them as if they were equations. So our first equation is y equals x squared minus 4, and then we have x minus y equals 2. So with respect to both of these, I noticed that the first one here is y equals x squared minus 4. This is a graph of a parabola. And so remember that with graphs of parabolas, at least in standard form or vertex form, I guess was what we would say, sorry, is this ax minus h quantity squared plus k. But what we can see really is when we write in this y equals x squared minus 4, that 4 is our k value here. And so really this is the graph of y equals x squared shifted down 4. So let's go ahead and start there. We say shifting down 4, 1, 2, 3, 4. We would see that the vertex would be right here. And with an a value of 1, this means as I go right 1, I'll go up 1. And so because we get this parabola right here, we could say that because we have a greater than or equal to, we're going to draw a solid line through these. And so we can see that my parabola would look something like this. If I could make it look a little bit cleaner, that'd be great. We say this here, and then we'd have symmetry on the left side, and this would be solid. So to label this, we say this is y equals x squared minus 4, and there's its graph. Now our second constraint here, this looks like a line in standard form, ax plus by equals c. And so we're going to go ahead and graph this by finding its intercepts. When we look for its intercepts, we're plugging in 0 for x and y here to find our y and x respectively, our y and x intercepts. So we say plugging in 0 for x, we would get that, I suppose here, negative y equals positive 2, so positive y equals a negative 2. And plugging in 0 for y, we're going to get x equals 2, so we get 2. So let's go graph both of these points here. We say 0, negative 2 lies here, okay? And we'd say that 2, 0, 2, 0 lies right there. And so connecting these dots, okay, looks like we get this graph right here. And we want to make sure that we label this x minus y equals 2 right there. So with respect to what the system solutions are, well, we could go back and we could test the point on both of these and shade appropriately, but what we're looking for are the common solutions. So we say the solutions to the system are where these two graphs shade together. And so we'll pick a point to test, and 0, 0, as a matter of fact, 0, 0 is on neither of these graphs. And so we could test it because it's clearly on one side of them. So testing in our original inequality, y is greater than or equal to x squared minus 4. If we were to plug in or substitute for our y and x values here, we say y is 0, x is 0. What we get is 0 is greater than or equal to 0 squared minus 4, or this, which says that 0 is greater than negative 4, which is very true. As a matter of fact, 0 is further to the right on the number line than negative 4. So since that's true, that means for our quadratic equation, we're going to shade towards the side of the parabola containing all of the solutions. And so in this case, that's towards 0, 0, since it made our parabola inequality true. So we're shading inside of this parabolic region. Now looking at our line, we'd say x minus y is greater than or equal to 2. When we plug in, say, 0 and 0 here, we get 0 is greater than or equal to 2, which, by the way, is false. And so since 0 is not greater than or equal to 2, that's a false statement. Then for our line, we're going to shade away from the side containing 0, 0, which means that in this particular case, we're going to shade downward here. And so I'm going to switch my color here because what we want to do is indicate the solution region. But with respect to the solution region, let's see if I can find my stuff here. Doesn't seem that I can. Well, with respect to what we have, we can say that the solution region would be this part of the graph where they shade together. And so to my best of my ability here, we could see that at the point 2, 0, we have what we would call, say, like a vertex or a bendy point on our region. And we can see that we have this other vertex here, looks like negative 1, negative 3 here, where it kind of meets up, and then we have our bottom vertex right there. But this would be the solution region, the set of solutions to the system of inequalities. So I want you to give this a shot on your own now, graphing these two, one linear, one nonlinear, and finding where they shade together and labeling it with the solution region. Cheers.